Good afternoon. Welcome to this last keynote and panel session of this Science and Technology Conference 2025. This Science and Technology Conference, we have been seeing amazing things, new technologies, science that is on the horizon for the future, also for the future of treaty monitoring. However, at this point, we thought it would be good to pause a moment and look back at where we came from. Look at the history of how the international monitoring system, the international data center, the on-site inspection, as we know them, have come to exist.
But how did we get there? It took a long time. How do you get there? So we have been asking this question ourselves to our colleagues, and we decided to answer this question. We will ask 3 eminent experts that have been working in the community for a very long time, and they will be sharing their knowledge with us today. So because to look into the future, we need to look into the past. So today we are offering you a travel in time to look into this history, this very rich history. But to lead us, we will ask 2 brilliant scientists, very young scientists, that will be with us, and they will be moderating this event, and they will be sharing their knowledge with us, and they will moderate these events.
I had the honor to meet these 2 youngsters in spring 2023. It was during an on-site inspection introductory course. And it was also the first time for themselves to meet. And we physicists, we say that we were not there during the Big Bang. Believe me, there was a Big Bang when they met, these 2. And I think that today you are going to experience it. And what I would like to say is that these 2 brilliant young scientists are our future. And I'm not talking only about the CTBTO future. I'm talking about the future for a better world. So please join us and welcome Seu Jesus and Maggie Wanyaga.
Good afternoon. It's such a great honor to be here on stage. And just to let you know, I'm this short. There is a step for me, specifically so that you can see me. So I'd like to say that it's such a great honor to be here alongside Seu to moderate this panel. And it's a chance for us to learn where we've come from, how did the treaty start, and how did the people who were there think about the organization as it is today. And I think we're going to take really great notes from it. So I'm going to go into the introductory section. And I am Maggie Wanyaga, an art scientist. I have been involved in very many international dialogues on the CTBT, as well as participated in many aspects in the organization. My great thing that I'm looking forward to is hearing from the experienced generation on how things are, how things are as we know them today. So it's your turn.
Thank you, Maggie. Really good to be here with you. And I don't need the pedestal, so this is quite uncomfortable for me because I need to speak on the side. I'm Seu. I'm just someone that, as a toddler, she used to go into the woods, grab all the little stones she found pretty, normally white quartz, but I didn't know that time what it was. And that led me to follow a path by studying mining engineering and then shifting into volcanology. And that's when I shifted to volcanology and moved to the Azores to do my master. I got the opportunity, I got a job offer to work for the IS-42 station in Graciosa Island maintenance team, and also do my dissertation while working with them. And that was the opportunity that brought me here today, that brought me to join the OSI team. We also organized, when I was back there, the ITW. And in just a casual conversation, because I was an ex-smoker, and you know how smokers are, they like to go outside, clear their hair, and then I met someone that was also a smoker, and in 5 minutes of a conversation, he invited me to join the OSI, and I did, and that changed my life completely. And being here, and last 2 years ago at S&T, also things just flow and brought me the opportunity of going abroad, across the Atlantic, and being right now doing a PhD in geological engineering, working with infrasound people as well, and also geological people. And it's been a really experience so far. What really motivates me in my life so far, personally and work-wise, it's my passion for outdoors, my passion to go to the field. It brings me all the freedom I always wanted for myself. I always imagined myself like a Lara Croft Tomb Raider, so I wanted to grow like that somehow. And here we are, conducting this panel between the younger generations and the old generations, and thank you. And we welcome you to the stage, Vittoria Oncha, Paul Richards, and Rodolfo Console. Thank you. Yeah.
It's such a great honor to have you here on stage with us. I will take this opportunity to give to our panelist, Victoria Wancha, to introduce herself and tell us about how she experienced those earlier days before we even had the treaty and most of the things in the organization as we know them today. So Victoria.
Okay, thank you. So does it work? Perfect. So I think we had a slide, introductory slide, but I'll start talking without it. Oh, here I am. Yes, so those 4 lines that I wrote here encapsulate my lifelong professional experience in this domain. So my journey began as a young scientist in the Romanian Institute of Seismology in Bucharest, where my first task when hired was to help my boss participate and help Romania's institute participate in the group of scientific experts technical test 2. Looking at some paper recordings recorded at Z stations that you see below my, my portrait. And the nice thing about that is that station became later part of the IMS network, so very proud of Muntele Roșu station. So here I put also 2 little seismograms, recordings of that time, so nuclear tests in that time. Anyway, later on, I became the head of Romania National Data Center. Then I was a Romanian representative in the group of scientific experts in Geneva. And in '95, my life changed, but the work continued in the same domain when I joined the Prototype International Data Center. First as a seismologist, then a director of operations. So this is where I met a lot of you, and I'm so happy to see my old friends, some of my old friends in the room. Anyway, after '97, my work continues after I joined Working Group B as task leader. And again, I met a lot of wonderful people. I learned a lot, and here I am. The last picture on the left was taken last week during Working Group B65 while I was chairing a meeting. So that's my story. Thank you.
Thank you, Victoria. Paul, would you like to talk about yourself?
Certainly. A word of advice to everybody in the room. Beware of opportunities to talk about yourself. I emigrated from England to the United States almost exactly 60 years ago with a degree in mathematics from Cambridge University, knowing very well that I did not want to be a mathematician for the rest of my life. And I lucked out in California, where I became a seismologist at the Caltech Institute of Technology. And I just have been so fortunate to find this classical mechanical subject and work with some of the interesting opportunities it has given me, for example, to be involved in a discovery about the Earth's deep interior. The fact that the Earth has an inner core, which is moving. It's a moon-sized object inside the Earth that is moving on a time scale that we can detect in a human lifetime. Wow, that's so exciting. I had the involvement over the years to move from theoretical work to the work of very practical issues in monitoring both earthquakes and explosions. I was invited by Ola Dahlman in 2006 to begin organizing the series of conferences. I think this one is, if you count from the very beginning, the 10th. And I appreciate the opportunity to find myself sitting in this chair. Thank you.
Now it's a chance to hear from Dr. Rodolfo Consol, our keynote speaker.
Thank you. Good afternoon to everybody. My job started in 1968 in the National Institute of Geophysics, and then changed the name into the National Institute of Geophysics and Volcanology in 1999. I worked in the seismological network development and also collaborating and coordinating the work for the new telemetry network, seismological network, and the digital acquisition and analysis of the data and the real-time analysis, and in the procedure for providing information for civil protection also, until now. Then I followed the work of the group of scientific experts in Geneva, meeting generally twice a year, and I started in 1976 until the final meeting that was in 1994. Then I also attended meetings, and I'm still attending meetings in the frame of the CTBTO after the signature of the treaty, in the context of the working group B of the PrepCom, still now. At the present time, I have the charge of president of let's say little body, little structure in Italy, which is called Center for Integrated Geomorphology in the Mediterranean area. It is a small center that is dealing with the environment problems and the civil protection and so on. Thank you.
Thank you, Rodolfo. Now it's time for your big presentation about the history of the group of scientific experts. A big round of applause for Rodolfo Consol.
Can I start the presentation? Okay, let me thank the organizers. Oh, this is not the first one. I must thank the organizers for the invitation. In particular, Mario Zampolli, who contacted me in 2025, but in March. And following me, inviting me, and following the development of this presentation very carefully. I'm also grateful with Robert Floyd, who gave a very nice introduction in his first session, in the first session of this meeting. Now, I have to be grateful with Seu for this nice picture and with the map road of these 80 years. Thank you. Because in my first slide, it was just a list of events, but it has become very nice now. Let me specify that I was born in 1944, so actually I followed all this way, this road, which is starting here with the first Trinity test, with the first nuclear explosion. The first, I divided these blocks in two colors. Actually, the first three blocks are military rather than political, the first explosions. Then the block of the blocks of political issues, political events, follow in the time until the starting of the CTBTO in 1996. So the green box belongs to scientific aspects. And I will focus in particular on the time that followed the first underground nuclear test in 1958. After 5 years, in 1963, there was the signature of the Limited Test Ban Treaty, which was forbidding the tests in the ocean, in the atmosphere, and in the space, but not underground. Why? Why not? Because underground explosions can be detected. It's not a very large problem, but it is difficult to discriminate them from the continuous natural seismic activity. Maybe 300 events of magnitude larger than 3 per year. And this circumstance, this challenge, forbid the signature of the treaty until 1996. And my presentation will be focused on this period. Then there is what you know better, even the young people knows, of the activity of the CTBTO in this city, and until the last box that is both red and green, because for the red aspect it is referred to the 80th anniversary of the Trinity test, and for the green part it is this meeting, this conference now where we are. So I start from 1958. In 1958, there was the first meeting of scientific experts in Geneva. It was held by the Conference of the Committee on Disarmament. On the right, you see the entrance of the United Nations office. And I went many times there, attending the meetings. But my first case was in 1973. In the last of these kind of scientific experts meetings. And on the left, you see the room where I went that day, and where the experts were exchanging, together with the diplomats, their views about the possibility of establishing a comprehensive test treaty. In 1958, during the first conference in Geneva, the British delegation suggested using a system of 160, 170 stations. Stations based as arrays of 10 sensors. Most of them on the continents, but also 20 on large islands and 40 small islands. And so it covered the whole globe, but it is the ideal network. It did not exist. The experts studied the capacity of the system, specifying that 90% of the earthquakes equivalent to the energy of 5 kilotons, maybe magnitude 4, something like that, could be detected. But this evaluation was strongly underestimated according to the following studies in comparison with modern networks. So actually, this system would have detected seismic events as low as magnitude 3. The oldest book published on this subject is this one, published in 1969 by the Stockholm International Peace Research Institute. And this is the book that I studied at first to prepare myself for the meeting on 1973 later. In this study, the experts hypothesized a global seismic network with about 50 to 100 high-quality stations. And the estimation of the capability was still underestimated, if you see the figures below. So we are now proceeding until 1973. In the conference of the Committee of Disarmament, it was the last meeting where I also participated. I met two young researchers from Sweden, Hans Israelsson and Ola Dolman. Maybe you know, some of you know the name because he was the first chairman of the Working Group B in the PrepCom. And they presented some studies, not only the Swedish studies, but also others, and they agreed and they supported the idea of these two young scientists to stop the meetings of the experts that were held maybe once every 2 years, something like that, and to organize meetings of a specific body composed by experts in particular. Actually, this idea was supported by other delegations. In the right, you see a figure that was presented in this document, in the CCD 482. And when they presented the map of the present situation for existing stations at that year, that could be used for monitoring tests. In parallel, these two scientists from Sweden published this book. And you see that on the top right, you see nearly the same figure as before. Not exactly the same, but nearly, with the existing stations in the world. Look at how few stations there were in Africa and in general in the southern hemisphere. And on the bottom left, you see the threshold, the capacity in terms of threshold magnitude for the long period system. In this case, there were no stations, long period stations to the south of the equator. And you can see the magnitude that could be detected for surface waves. On the right bottom, you see the study of the capacity of location. The numbers on the right are the uncertainties in kilometers. And you can see there is a sharp decrease of the capacity below the equator. This is because they were supposed to use existing stations, not planned stations. So now we are at the first mandate. The CCD decision of 22 July established this so-called ad hoc group of scientific experts, the acronym GSE, that I will use frequently now. But the whole name is not just in what is written in blue. The whole name, the official name of the group is ad hoc group of scientific experts to consider international cooperative measures to detect and to identify seismic events. There is no any term about explosions, no mention of nuclear tests. So the mandate does not contain the words explosion, nuclear test. The word identify maybe signifies something that is discriminating or maybe evaluating it is if an event is natural of an explosion. At that time, the tests carried out in the world were in the average one for a week. So the task assigned by the CCD to the GCA were in this scheme of three places, three parts. First, the global network of seismological stations. Now we call it the seismic part of the IMS in the context of the CTBTO. Two, the transmission facilities. Now, in the CTBTO, we call it the Global Communication System, GCS. Then the third refers in practice to the IDC now. What is the analysis, the place where the data are collected and analyzed. And you can see here that there is 2 times here the word centres. The idea at the time was that there would be more than one center. This is of political reasons. There were the Cold War, there was the Cold War and the 2 blocks, you know. So in during the first mandate, the GSE produces a report, and these 2 figures represent the idea of the monitoring system that could be established and the threshold, the magnitude threshold of this system for short period detection, for POAs in practice. And you can see on the left that this system, this network, resembles very well what is now the primary seismic network in the IMS. Now, on the left, you have the idea of that time concerning the transmission of the data, the transmission system. It was based on the WMO, the World Meteorological Organization in the world that already had some of this kind of system, and it worked in circular way. That means that all senders, all the data sent by all senders was received by all receivers, not only by international centers, by all. So for instance, below, in the bottom, one seismograph station was able to send the data and also to receive all the data. On the right, this is something similar to the Tokyo subway network, but really it is the WMO system, transmission system, with the main trunk on the top, which had the capacity of 2,400 bits per second. And the small ones had the capacity of 80 bits per second. That means about 10 bytes per second. It was enough just to drive a teletypewriter. They were sending telegrams, not waveforms. On the left, you have more or less what I have said now. And on the right, you have what was supposed to be reported on that global communication system. For each event at each station, the owner of the station would have read the seismogram not sending the seismogram to the center, but sending only the parameters obtained from the seismogram: arrival time, phase name, of course, amplitude and period. But the last two dots refer to some kind of discriminants. We were expected to send the maximum amplitude in the first 5 seconds of the seismogram, and in the next 25 to 30 seconds. The ratio of these two amplitudes represent what is called, it was called, complexity of the seismogram. It was a discriminant between earthquakes and explosions, because earthquakes are generally more complex in the waveform. This is the photo of the end of the first mandate in March 1978. This is interesting to see something. You maybe can recognize 2 or 3 people here, including myself. On the right, the last but one on the right is Ola Dolman with dark hair at the time. And the chairman in the middle was Mr. Eriksson from Sweden. Another thing, there was an Indian representative. He's near the lady in the middle, and no French here, no China. You can also recognize Frod Ringdal near the chairman, to the left of the chairman. This group was a mix of pure scientists and real experts in the explosion monitoring. This was a mix, and I belong to the category of the scientists, pure scientists. Okay, this is to give you this is the time that I exceeded. Plus 0.2. Okay, this is a pure to show you the environment. What I have to notice is that the places were strictly in alphabetic order, not as now in the working group B. This is a photo with more people. Now there is one from China, and other people, important people like Peter Marshall and so on. So these are workshops that were organized. They are similar to the present time national data center workshops in the structure. This is a concept that would be worth of some comments. Anyway, there was a lot of discussions if the data would have been sent to the 4 international data centers, not only one, directly and automatically, or passing through the IDC. So the Eastern people would like to have the IDC monitoring the data before sending. And the other people, the Western people, were in favor of automatic transmission. And the discussion that took a lot of time, was provided by the expert Peter Marshall, who suggested to use the word expeditiously, not automatically or instantaneously, not instantaneously, expeditious. This word was accepted by the whole group. This is the starting. Now we are approaching the present time. We are now in 1993, the establishment of the CTBT ad hoc committee. They are diplomats with the assistance of some experts. And this is a photo from a workshop held in Erice. There are new people like on the right, on the extreme right from France, Bernard Massinon, and so on. You may recognize some people, also the lady on the last but one to the left. This is important. We produced a report, a book, and this book, there was the last article was by Peter Marshall, sitting with a gray suit here in the center, who was entitled concerning the OSI. It was the first time that I heard the name of OSI. This is the map of the GSET alpha network. Alpha means primary stations in practice, and beta was for auxiliary stations, and the words alpha and beta were removed by the treaty, not to confusing with radionuclides. And this is a further step, is the creation of the GZ3 Prototype International Center. And then we are at the final meeting of the Working Group B. You can see here also somebody that you know, in particular, Hein Hack, the last but one standing, who was the chairman of the Working Group B. Or there is also Jennifer McBee near the chairman. Now we are at the present time. There is the present situation of the scheme of the International Monitoring Receiving, and this is the place where the PrepCom now works in the Vienna International Centers. Thank you for this presentation, for listening to me, but I would like to remark two things. One is to look at the link to the Nobel Laureate Assembly for the Prevention of Nuclear War that was held in occasion of the 80th anniversary of the Trinity test. And then the last one is that a full version of this presentation with the double of the figure and of the information is at that link. Thank you.